Okay, so let's look at this second example now, where it's not connected over a pulley, but there are still two objects connected to each other. So in this one, now we have two blocks that are connected by a massless string. That's just another fancy way of saying that the force of tension is the same on both of them, and they are pulled to the right across a frictionless table by a disembodied hand as shown. If the hand pulls with 20 newtons of force, we want to find what is the tension in the string. Okay, so just like before, we're going to set up a free body diagram for both. So I'm going to say there is a normal force up for the 3 kilogram block, and there's 30 newtons of gravity because mass times g. That might not really matter because I might not even need that number, but I'll just write it anyway. And then over here, I'm going to draw it a little bigger because it's a heavier block. So there's a normal force up for that 10 kilogram block, and there should be 100 newtons of gravity for that one. Okay, so now when I draw this, let's start with the 3 kilogram block. If I zoom in on the 3 kilogram block and just ignore the other one, I see that there's a rope attached. There is no friction, it said. So I'm not going to draw any friction, and I'm just going to draw a force of tension this way. Okay, and then if I zoom in on the 10 kilogram block, ignoring the other one, I see that there is a rope attached here, and there is the applied force from the hand. So I'm going to draw that force of tension in, but guess what? It's the same rope, so it's the same force of tension between both of them. I don't need to say FT1 and 2, it's just the force of tension. It's the same one. Those are equal to each other. And then I have the applied force going to the right, and that one is 20 newtons. I'm going to draw it a little bigger because I'm assuming that it's accelerating to the right. All right, so now let's write our equations for each of them. For the 3 kilogram block, it's just going to be the force of tension is equal to MA. The winners and losers, there's no loser, it's just the winner of tension. So FT equals mass times acceleration, or 3 times A. For the other one, we're going to get a winning force of 20 newtons minus the same force of tension, FT, is equal to mass times acceleration, or 10A. Okay, so now I see I have two equations and I have two unknowns in each equation. So which one do I substitute? Well, this is asking me for the tension force, so I probably don't want to substitute out the force of tension because I'm looking for it. So instead, I'm going to try to substitute out the acceleration, and I'm going to work with this equation because this one has a lot going on, and that's not fun, so we don't want to work with that. So let me bring my 3 over, so I get FT over 3 is equal to A, because now I can take this and I can plug it in for my acceleration in this equation. So once I do that and I plug it in, I'm going to get 20 minus the force of tension is equal to 10 times Ft over 3, because that's what I said my acceleration was from that other equation. So now I can plug it in and say, okay, 20 minus the force of tension is equal to 10 Ft over 3. So I'm going to want to multiply both sides by 3, and I'll get 60 minus 3 Ft is equal to 10 Ft. And let me bring my force of tensions together and get 60 is equal to 13 Ft. And once I divide both sides by 13, when I do 60 divided by 13, we get a force of tension which is equal to 4.6 newtons. Okay, so this is our force of tension that we get between the two of them. And again, it's that same force of tension for both block. And that is the key with these two-body questions, is finding out which force or what thing is going to be equal. And if there's a rope, which there pretty much always is a rope, that is the one thing that is the same for both block. Just like it was in that other example, right? The force of tension was the same for both because it's the same rope. This is the part that can be tricky because you look at it and see that there's something in between and maybe there's two tensions and you get confused. But just know that there's one rope over that pulley and it's going to be the same tension. Okay, so then at the very end, how fast will the blocks accelerate? Well, this is actually really easy now because I know from before I said Ft over 3 is going to be equal to A. I could also plug it into this bigger equation over here, but that's a little bit more work, so just make it easier on yourself. So the force of tension was 4.6 divided by 3 is equal to A. So the acceleration of the system and the acceleration of both blocks is going to be 1.54 meters per second squared. And that's that for this question. Okay, I want to do one more example because as a reward for watching this video, I appreciate that you are motivated and you are watching it. I mean, it's what you're supposed to be doing anyway, but I also know that some of you guys probably will be skipping through it. So I will tell you guys right now verbally, this kind of question is going to be on the test, okay? This type of pulley question is going to be on your test, and I want to make sure you understand how to do it. So that is why I would say work on those questions in your practice test and in that worksheet for today. I want you to do numbers 2, 3, and 4 on the worksheet because they're going to be good practice. There is one type of question I did not show you how to do. It's going to be on the test, so I want to show you how to do it right now. Imagine instead that, oh my God, that is such an ugly table. Okay, we have a table, and on top of the table is going to be a block. The block is going to be attached over a pulley like this to another block, okay? So look at that and look at this one from before. These two are both pulley questions, and even if this one is attached over the table, the force of tension is still the same for both. Okay? So in this one, what we're going to be doing in our lab tomorrow is we're going to be setting up something that looks like this, and we're going to say that there is friction. So tomorrow in our lab, we're going to be making this setup, and we're going to be solving for friction, for the coefficient of friction. So let's figure out, let's do one example like this together, okay? I'm going to say that this is a 2 kilogram block, and over here, this is a 5 kilogram block hanging off the end. Okay, so because of that, I already know that it's going to be accelerating this way. So then I want to figure out what is the force of friction. All right, so let's say the acceleration that they're going over with is 2.1 meters per second squared. And I have their masses, and I'm looking for friction. That's all I need to know. So step 1, draw the free body diagrams. For the 2 kilogram block, we're going to have tension this way. And we're going to have friction pulling against it, but I know the friction is losing because, again, it's accelerating down over, so it has to be losing. And I'll add in, okay, I also have normal force, and I also have gravity on this block, and those are going to be equal to each other. But why don't I just go ahead right now and say that the force of gravity for this block is 20. All right, and then when I draw it for my 5 kilogram, again, I know it's accelerating down, so the force of gravity of 50 newtons is going to be bigger than that force of tension. And now I can set up my equations. So now I can say, for this one, the force of tension minus the force of friction is equal to 2a, because that's its mass. And then for this one, 50, the force of gravity minus the force of tension is equal to 5a. All right. So what am I looking for right now? I'm trying to find my force of friction, right? I have 2 equations and 2 unknowns. I don't know tension and I don't know friction. I want to find friction, so let me substitute out my tension so that I can do that. So I'm going to rewrite this equation here and say my force of tension is equal to 50 minus 5a, because now I can take that value and plug it into my tension here. That is going to give me my new equation, 50 minus 5a minus the force of friction is equal to 2a. All right, and the acceleration in the question told me it was 2.1, so let me plug that 2.1 in. 50 minus 5 times 2.1 minus the force of friction is equal to 2 times 2.1. All right, so 5 times 2.1 is going to be 10.5. So 50 minus 10.5 minus friction is equal to 4.2. So now I'm going to simplify this. I'll add my force of friction to the other side. And I'm going to subtract the 4.2 from both sides. So 50 minus 10.5 minus 4.2 is going to be 35.3, and that's equal to my force of friction. All right, and we could take it a step further, and we will tomorrow in the lab, and say what is the coefficient of friction, right? And at that point, you're just going to say, well, let me figure out what is the normal force acting on the box, and that's going to help me find my coefficient of friction, because we know that friction is equal to mu times the normal force. That is just a way to take it a step further, and that's what we're going to do tomorrow. But again, I know these things can look really complicated, but at the end of the day, all you're doing is you're drawing a free body diagram for each block, right? You're still doing winners minus losers for each block. And then you are figuring out which equation to plug into which one. Now, if you did it the other way, if you decided to say, let me plug in acceleration, you'll be able to solve for the force of tension, and you'll be able to get your friction from there. You might take a step further, but you're still going to get there in the end. And it's the same over here as well. If you decided to say for this one, well, let me go ahead and solve for this first, you would still get to your final answer. It's just a step further. So what you always want to do is you want to look at what the question is asking you to find, the acceleration. That means I don't want the force of tension. I don't need it. So I'm going to try to substitute it into the other equation so that it just goes away. And I am left with an equation where I'm only looking for the acceleration. Okay, so that is everything. That is the very last of all the stuff we need to know. If you have questions, please send me an email and I will try to help you. We will go over this again tomorrow. So I really want you to do the number 2, 3, and 4 on the worksheet so that at the start of class tomorrow when I'm back, we can go over any questions you have about them. Because again, this one right here, the pulley and the 2 hanging masses, is going to be on the test. This one, where there is a pulley and things are sliding off of a table, this is going to be on the test. So I want to make sure that you understand them. So try them on the worksheet. If you have questions, email me, and we'll talk about it again tomorrow, and we'll practice it with a lab. But other than that, I hope you guys have a wonderful day. Thank you for watching, and I will see you tomorrow.